Well, hello. Um, it's an honor to be here, and to all of the delegates and officials. I look forward to talking with many of you as the day goes on. So it's looking like a very good first summit. So I am here to just introduce you to a few interesting innovations in transportation, but also how it relates to the development of in a sense, the urban landscape, the rural landscape, how it affects productivity and economic development, and even how innovation at its core it plays a key role, because the company that I have been founding is very central. Is a very central aspect of it, innovation, and so really combining all those features under one roof is quite interesting. And also, I come from Toronto, so I just flew here the other day, and it's very nice to be in Tokyo. And I hope to give you a little bit of an interesting mix of the contexts between different countries there. My name is Ryan Janzen. So my background is partly in the research world, the transportation world, and trying to work with the private sector and governments worldwide to implement some of these new innovations. So looking forward to sharing a little bit. But really what we want to focus on here is how to combine these things. So what we have is very distinct economies in different countries worldwide. We have very complex city landscapes that are changing at a rapid pace. And we also have governments and the private sector that are trying to design those urban landscapes with transportation included. And so all of those connections, how can we form those connections with technology at the same time? But the important aspect to consider is individual people. So how does this affect the quality of life, productivity of individuals? And it's almost a psychological aspect when we are designing new transportation to understand travel patterns that human beings naturally follow when we give them a new transportation option. And so people have even made very interesting studies of human motion through cities analogously to water flow, so like a river flowing through cities of people. And so all of these effects are almost a cause of nature. So how does the human experience manifest with many people at the same time? And so how do we intelligently design those things? And so we can really look at a lot of new innovations in transportation, and I would even split them into some of these different categories, because many people, there's quite a bit of interest in driverless cars, automated vehicles, and so on. But in essence, many of those innovations are taking an existing vehicle and adapting its control. So we use software to control an existing mode of transportation. And so, for example, with driverless cars, we need advancements in cameras and computer vision and signaling. We also have ride sharing and artificial intelligence and even swarm behavior of vehicles. So AI, all of those things affect transportation systems, but they are software improvements. And what I'm going to, one of the points I'm going to address is how there is a limit to how much we can do with software on its own. And at some point, we really need to also look at the hardware, as in building new vehicles and new modes of transportation. And so that real contrast, if you see the rivets, the nuts and bolts, and the manufacturing, there are many manufacturing opportunities in the countries that our company is working in, and I'll explain a bit of that. But we also have unmanned aerial vehicles, drones. We have advancements in aircraft, and even advanced robotics for parcel delivery, cargo delivery, electric vehicles, so increasing efficiency, and also tube transportation, which I will talk about. So that we have hardware and software advancements, and across those categories, we really, innovation in many different fields that we work in can be thought of partly as incremental work. So if we make an automobile 1% more efficient, or a jet 1% more efficient, that is useful. But that would be called an incremental change. So an incremental change where we're slowly advancing, but sometimes we come across a major new improvement that takes a quantum leap forward. And that is really what I'm interested in expressing, how we can address climate change and congestion in a radically new way with new modes of transportation. But we really have to make sure that those modes of transportation fit into the cities and the countries that we design, or we govern, or we participate in. And so urban design is an important consideration of all this technology. And so how do we take existing vehicles? One example, it's quite interesting. So in the Canada, there was recently elected one politician who is very much in favor of public transportation, but only in a certain type of vehicle, and rejects all other types of vehicles for public transportation. And so that's an interesting case where we may end up having a very unbalanced transportation network where we don't have that full network approach. And I think that those types of considerations are important worldwide, and how it affects how people can get from point A to point B. So productivity, social innovation, and so on. And so all of these innovations, we have incremental improvements and fundamental. So this is really just referring to the hardware aspect. So we have changes to these vehicles. So for example, bicycles and aircraft have been around for quite some time, and it's quite amazing how aircraft have not fundamentally changed, at least in the overall design, for quite some time. But then there are other new, drones and other robotics transportation that are quite new. But there seems to be a missing gap. So on the left to right horizontal axis is the scale of development. So that refers partly to the number of passengers, the size of the connection between cities or very local connections. So at a very large scale, we can provide very good solutions with train transport, but what kind of innovations can we pursue at a big scale that are fundamental improvements? And so that is why TransPod and the TransPod system are being developed. So this system is a global project initiated in Canada and expanding to France, Italy, the United States, and a couple of new collaborations that will be announced soon in 2 Asian countries. This is a major industrial project for a new type of vehicle and infrastructure. So the TransPod system is a system where we have passenger vehicles inside a conduit, a low-pressure environment where we connect passengers between cities at over 1,000 kilometers per hour. So this system is a major industrial project, but the basic principle is simple. So with these vehicles, when we have travel inside a tube with lower air pressure to reduce friction, we can achieve a higher efficiency and a higher speed. This concept is not exactly new. It was introduced about 100 years ago by 2 people. One was a Russian professor and also an American rocket developer. And it was just introduced as a concept of tube transportation in 1909. And it remained as a concept for many years. And only in the 1970s and so on, vacuum pump technology improved, but it was still, there were some major technical hurdles. Now recently, at least in the United States, which is a little bit separate from what TransPod is doing, the concept was popularized a little bit more under the term Hyperloop is just a different name for an existing concept, but I prefer to call it more rigorously, I call it tube transportation in general. And so what the TransPod system is a next generation of tube transportation with new technology to make it work. And work much more efficiently. So this new technology, this new generation is what we're developing. Now, if you look at the picture, you will see through this tube environment. The actual construction is being designed with spiral welded steel. So it's a steel tube, and it's just shown here clear so you can see what's inside. So that vehicle is inside. And so the vehicle is being designed for levitated propulsion to carry passengers between cities. And so one can ask, well, why are we doing this? Well, you know, especially for productivity's sake, worldwide we have some major issues to tackle. One of them is congestion. And so we have really the lessons learned in Asia, in North America, and many other countries, is that if we allow development to proceed without a policy for how to design an intelligent transportation system, then we can allow the occupation of those routes to be filled to capacity. And even sometimes when there's a bit of an issue, when you increase highway capacity, then of course then it soon reaches another limit, and it also causes congestion in the local urban environment too. So there's a very important need for mass transportation solutions. And so also climate change. Now, one of this is actually the projected temperature increase worldwide over the next 100 years. And it's amazing how after all of the work that worldwide that we have been doing to try to address climate change, this is still the case. And so there's significant more work to do ahead. And on the productivity front, it's quite interesting how productivity has not been recognized enough as a consequence of climate change, where we have lost labor productivity with higher temperature overall worldwide. So there's some important issues that need to be addressed. And we have to ask, well, why is this still occurring? And you can actually track energy use worldwide. On the one side, we have fossil fuels or renewable resources that are extracted worldwide. And then we have uses on the other side. And so on the top of the left, on the right side is wasted energy. And so where is the problem? Well, a large proportion of the non-renewables are being used by the transportation sector. So transportation is requiring still a large amount of non-renewables. And why is that? Well, aircraft, for example, require jet aviation fuel. So they require fossil fuels. It's very energy dense. And so that is not going to change anytime soon. There exist fundamental limits on vehicles, and we really have to look at fundamentals of vehicles themselves. A rocket has to lift its own fuel, and so does a jet. A car has air resistance. This is why we need a true leap forward in vehicles themselves and infrastructure to carry them. And so fundamentally shifting transportation with high-speed routes like the TransPod system are one of those strategies. So this, I'll talk about several different transportation systems, but this one is quite interesting because the design of the TransPod system, well, it's being worked on especially so far in Canada and Europe. And so these are some future renderings with the projects that we're developing. And again, the history over the last several years, gradual developments in different countries, but now major industrial development of the TransPod system. And really the philosophy here is it's key to have advanced fossil fuel free transportation. This is a fully electric system. And so really to be able to connect people in a new way. Now, this is being done with quite a few industrial collaborators, partly in the aerospace and rail industries. So we're working with a company that worked on the International Space Station and the Mars Curiosity rover, as well as several aircraft manufacturers and rail manufacturers as well, as a few other partners. And so the basic idea of this vehicle, so this is shaped like an aircraft fuselage, but without the wings. So inside are rows of seats, and it's very similar to walking on board a jet when you fly. So rows of seats, and you go in the doors, and it's like an aircraft fuselage that holds the pressure. So it's designed for a comfortable ride. I'll show you some of the inside as we go along. And it's using magnetic fields to levitate off the bottom and propel itself to high speed. And so we have here a twin tube construction, so travel in both directions. With all the civil engineering, emergency escape, safety systems, and so on. And you see part of one vehicle rendered there. And so it's very important to design something like this for application in developed and developing countries in a variety of different contexts. And so the important factors when you consider agriculture worldwide, there exist problems with installing high-speed rail because high-speed rail. There's one actual group in Canada that came to us because they're an association of farmers that were very concerned about high-speed rail development over their farmland, and in that case, where you actually cut farmland in a strange angle. And bisect it, and all the property acquisition costs. The design here is to be elevated, where a farmer can still drive a tractor or go underneath, and so it's a minimal impact upon the landscape. And so then this vehicle, it's a bit larger than it appears in the picture. It's actually similar to a train carriage or a small jet aircraft on the inside, which pulls into stations that we'll see. And of course, all the engineering of all the subsystems with all these industrial partners. And then we have to very carefully think about how we design a transportation system similarly to the expertise that's, so in Japan and many other countries, obviously the expertise in the rail industry is very good. And so we want to really pay respect to that expertise and build upon it, where we have an aerospace vehicle now. It's a bit like a spacecraft that's built like a jet and it operates like a train. And so we have to carefully think of the operational characteristics, make it work for some countries where we have very high population density, and other countries where cities are more spread out. And really, an important fact is designing something that works in very developed countries. For example, in some cases where there's significant private sector interest in building a line, but there are also many countries where a government wants to install public transportation as a public service. So if they want to increase productivity or provide other social economic benefits then it's very interesting because let's say United States is one example where the private sector is perhaps the dominant funding partner in building a line. In other countries, it's the public sector and governments which have to be very involved, or some places a mix and public-private partnerships. But satisfying government objectives, addressing climate change and congestion, we really have to combine that with providing something that works for individual people. So individual passengers, we have to provide something that's convenient and very different from, for example, aircraft travel. So take the example of when you fly in a jet, you often have to buy your ticket long in advance, so days, weeks, or months in advance, and then you have to go to the airport at that exact day and the correct time. And even when you get there, you might get bumped from your flight. The flight, even when it takes off, might get diverted to a different airport. It's subject to weather and storms and turbulence, and you might lose your luggage. So there are some convenience aspects to aircraft where with this system, we want to make it much more like a high-frequency rail experience, so much more serendipitous. If you wish to travel to your job or to a trip just for the afternoon, you show up at the TransPod station, you pay for your ticket, wait for the next vehicle to pull up, and you get on board. So you just wait a few minutes, and then you go. So it's a very big shift in the philosophy. Now, this also is being designed for cargo too. So there are cargo applications that are quite interesting, and they can be on the same line. And so that combination of speed and convenience and having something that's faster than a jet, about 3 times as fast as high-speed rail, but also the convenience of a rail system. So those aspects on productivity, on social welfare are very a big part of the considerations here. And even, we can consider for the climate change aspect, there's quite a bit of pollution that's caused by jets, like I said, because when a jet takes off, quite a bit of its fuel is used at the beginning of the flight to get up to altitude, and then less fuel is used afterwards. So if you have 2 cities that are quite close together for a short-haul flight, then the jet basically goes up and down again. So quite a bit of fuel is wasted in that kind of case. And that is the ideal application of a TransPod line for these short-haul flights. We actually talked with there is even interest from airlines and airport authorities. So we're working with 2 global airport authorities that own several worldwide that are interested in installing a TransPod line where their airports are constrained in physical space. They can't expand anymore. And so they need a solution. So the solution that is being proposed is to build high-speed TransPod lines between major airports, so those airports can eliminate their local short-haul flights between those cities and then add more long-haul flights and earn more revenue. So this is an interesting possibility. And so per kilometer, there's quite a bit of fuel wasted or used. And now we have improvements with train networks, and then we've been able to have a solution that is quite more efficient with TransPod because of the higher speed per kilometer. Now, we really have to think about what impact does this have on our societies, and how do we design for the future? Now, so for example, economic effects are very important to consider of any transportation system. So we have to consider this if we're building even highways and so on. So the costs and the benefits, and so this is the global forecast is quite interesting, but we have to customize that for different regions. Now, this is just one example in Canada where we're designing one of our lines between Toronto and Montreal. And so this is a high-speed route that is, one of the problems here is it's yet another example of congested highways. So we have 10,000 trucks per day that travel along that route, even starting from past it towards the United States, where these trucks cross the border. So there's quite a bit of productivity challenges, because if we can shift that type of transportation, we even have been in talks with two of the major cargo carriers, DHL and FedEx, where they have regular flights that go into Toronto and then another flight to Montreal. If they can eliminate one of those per day, then that's quite interesting for them. And so then we look at the actual operating revenues and hours of savings, and of course CO2 reductions. So all of those things, both the government objectives at a very high level, and also the quality of life, productivity on the individual level, are very key. And so just to focus on congestion, because there's quite a bit of that's an issue in Asia. It's equally an issue in North America and many other countries. And so you can actually, it's a bit of a different problem in the different countries, but there are various rankings. So these are just two examples where we see, so these are the most congested cities worldwide, according to two different rankings. So we have some representation from Asia and others, so including Thailand, Taiwan, China, and a few other countries, as well as North America and Europe. And South America. So there's so these challenges are very key to address, and so productivity, of course, is an issue when people are stuck in traffic, and it's amazing how the level of concern, even in Canada, about lost productivity with congestion is it's in the news. But then it's amazing how some of the problems are so much worse in certain cities in Asia, and we really have to look at how to tackle those in a way that that overcomes the kind of momentum that's already there. People getting used to those issues. One of the issues, actually, even in Toronto, is the productivity losses are quite severe, but also the public transportation system in Toronto. You can actually assess the productivity of the Toronto transit system, and it's actually one of the highest in the world. The productivity of the transportation system, because somehow they've been able to invest. The money that they have invested, the number of passengers it's being able to carry per day is quite high for even Canadians who are fairly conservative and are hesitant to spend too much public money on some of these things, which is kind of a shame. But somehow they've been able to make this work quite well. But of course, the impact on people and businesses. Now, on businesses, we have freight transportation, and quite a bit of that cost is in labor. So we have labor needs, where in some countries there's a shortage of labor, but also we have limits on hours per day that truck drivers can operate. So if we can switch to automated modes, so automated vehicles, automated individual vehicles, and also TransPod lines, automated trains, we really have to look at how we can combine those intelligently. And so this is one way that those can be combined under one roof. Because those two hubs represent two major cities, or two or more, and so all of these innovations in transportation, if you look at the left side and the right side, what we call the last mile, so all of those can have a place and must be considered if we future-proof our countries. So those are absolutely necessary to transport people and goods to the central hubs. If we design transportation intelligently like that, then we can have a well-designed network approach where high-order transportation is used where it's most effective. It's less effective if we simply send an automobile or a truck from the very first garage or origin all the way to the destination. So if we can intelligently connect, then that helps quite a bit. But also connecting, so at the different levels of industrial development, this is an example where, for example, the TransPod system, we have labor and materials and equipment, so passengers and freight. So the pink lines represent how we can transport passengers, and the blue lines transporting freight. And so in the whole development process, all of those things, we have to consider our economies and manufacturing capability. All of those steps are very important. The labor step is very important. So how can we have individual people arrive at their work in the morning and get home at night? And how can we then distribute those produced goods, so wholesalers, and then eventually to sellers, and then finally to consumers at the far end, so people who wish to buy those goods. And so then that's people transport as well. And so if we see this, it has a very important effect on supply chain design. So the productivity of the whole supply chain is key when we design this transportation. So we have to consider the size of the goods, the passenger capacity, and so on for all of those different aspects. And so this is, of course, very important for developing countries. So there are quite a few challenges that we want to overcome, because being able to future-proof the transportation design must consider new transportation developments and also how to design sustainably, and really to have a smart policy. So because we can often involve the private sector, we can involve foreign investment in our countries, but it is very important to be able to set those policies intelligently. And so even in Canada, the Canadian context, we see cases where the city governments and the national governments have certain policy goals, even designing the urban fabric. We have cases where there is even one neighborhood in Toronto where Walmart was proposing to build a Walmart store in the middle of the city. But since many people recognize that there are individual shops that have a very long developed culture in those neighborhoods that would be put out of business, so the city actually had to pass a special law that would not specifically call out Walmart, but specifically prevent a store of that type to be installed. And so that's the effect on the urban landscape, but on the transportation networks, that's key. So how can we use government to set the policies for transportation design? And so foreign investment, for example, this example in Ethiopia, where it's causing very good productivity improvements based on the travel time that we reduce. So this is an African example. But there are many examples in every country where we can intelligently have foreign investment. And so that is for many different transportation systems. I'll just show you an example with TransPod. So this is an example of a TransPod station that is being designed with our architecture division. And so this is working with a developer where there's a major new sector of the city in Toronto that is larger than the city of Venice. It has waterways going through it. It looks similar to Venice, except it's an undeveloped zone in the city. And so this is finally a chance for the city to build it right. So build it in a carefully planned manner with parkland, with mixed communities, with business combined with residences in the same mixed community. And so they're building a multimodal transit hub, and they wish to have a TransPod station combined with a conventional rail and a metro line underneath, actually. And so if you... I think the overall picture I'll show you after, but this station, maybe what I'll do is play this example. So this multimodal station is being designed and currently in the works. It's very close to the center of the business district, but just a short distance away. So this station is multi-level, and I will just go ahead a little bit after we have gone up to the top level. So that's the TransPod level, and you'll see how this is being designed quite different than an airport. So even though the speed and the ticketing and so on is somewhat similar to an airport design, we have to make it very efficient for passengers to load, so it has to be in a way quite similar to a high-speed rail station. And so this is the overall multi-platform section, because the goal is to have a very high vehicle throughput on the line, so we want to have as many passengers able to go on the line as possible. That's why we have parallel platforms. So we actually load passengers, even though it's a line, we have stopping stations at different cities, so that's why there are different platforms. So once you've paid for your ticket, this vehicle is in an open air section, so it's already gone through an airlock from the high-speed line. There's a docking procedure where it joins to the access door, and so this is a bit of a Spanish solution style loading, where passengers leave on one side of the vehicle and enter on the other side. And so then that increases the throughput, and then the vehicle accelerates magnetically into the next section, and it goes. Okay, so that type of station design is just one example in the Canadian context, but obviously for different countries, it's quite different design, depending on how many cities you're linking, depending on how many passengers are expected, and the cargo mix. So because, for example, the cargo side, when we have peak flow of passengers, so in Tokyo, we have the peak hours of the day for passenger travel. So with a TransPod line, the optimal time for increasing the cargo is at night. So they can be mixed together in the same line, and then increase the cargo capacity at night. So interior design is a little bit similar to an aircraft interior and train interior, but what's different here is that since it doesn't have windows, it's inside a steel environment outside. So this is actually using display screens on both sides to actually show, once it goes into the main section, you actually will see the landscape going by on these display panels of the actual scenery that's outside at that. So it's a good way to see the countryside. But also working with an optics manufacturer where at the ceiling, it actually is able to simulate natural sunlight. So as if the sky and the sun were not here, but far in the distance above you. So really making a comfortable passenger experience. Where people can have a smooth journey. So this is just, of course, depending on which cities you're traveling between. And so those pictures are available on the web if you'd like. So the cargo vehicle is also being designed. And so with standard shipping pallets, so we have to think about the productivity of the shipping industry or the freight industry, and we really have to think about what type of loading containers would be used in specific countries. These are standard multimodal pallets, but also then your standard wooden pallets are also able to load inside here. So ULD containers and so on. And so this is designed for a separate hub, a trucking hub connection, where the shipments are loaded in the hub and sent on their way. Now, corridors. Oh, by the way, this image you're seeing a little bit overhead of that multimodal station that you saw before. Now, so many different countries that we are looking at. So, of course, this is a multi-year development project. Just like an aircraft development program, it's a major industrial development worldwide. Meanwhile, at this time, we're in preliminary negotiations with some cities and federal governments. So, for example, we met with Macron, so the president of France, about developing this in France. We have met with Trudeau in Canada. There's also the government of Italy is interested in pursuing this. But then there are other routes that are quite interesting in North America, in Europe, that are potential routes. Potential routes in Australia, South America, that we're going through computer simulations of and the engineering design, preliminary design. In the Middle East, of course. In different parts of Southern Asia, and of course India as well. And so these are just examples. And I would be careful about. We've announced some of the actual major routes that we're pursuing. I'd be careful what you read in the news, because different people have postulated about different routes that. For tube transportation, and some of them are the actual ones we're doing. Others are not what we're actually doing. So that's important. Now, and just a very brief sense, because for us, for at least the TransPod network and the system, productivity is very much linked with innovation, and that is why we're working with so many different companies in different countries worldwide. And so a couple of them here, and we'll be announcing a few more partners quite soon. And also being able to, so the productivity of even the industrial development, choosing where we ship our equipment. This is actually the largest vacuum chamber in Europe, where we are doing, this is for some of the testing of the vehicle subsystems. This is otherwise used for spacecraft, but we're doing the parts of the vehicle, and we are now developing in France what will be the world's longest 3-kilometer test track of a tube system, and part of the goal is to test this at a high speed. So this is a 3-kilometer long line that is, the construction permits are being submitted in the coming weeks, and working on the financing of this track for completion in the coming years. And so this is for high-speed tests. We're also developing another test track in Canada, and there may be other opportunities worldwide, because an important aspect is certification and safety. So making sure safety and certification are at the core of what's being built here. And so that process, following the rail certification systems and from the European Union and the Canadian governments, as well as aerospace. Now, one other interesting note is productivity in innovation. Now, here is the TransPod example, but I'll show other examples. So this is a increasingly multinational project, and we'll soon announce more collaborations in Asia that are now upcoming. But it's important for us, since it's such a multifaceted technology. So it's combining the aerospace industry and the rail industry. It's important to find the best partners worldwide. And so this is really interesting for other types of fields. And you could almost generalize to an analogy of a conveyor belt. So for many types of innovation, in some countries that focus quite a bit on manufacturing itself, I would propose that the manufacturing, the benefit to that country of manufacturing on its own is important, but that is only the end of the line of the innovation and development. And so you can start earlier. You can focus for increasing your talent pool, increasing productivity in industrial side, R&D. You can start a little bit earlier, or you can start during university development. But really, the initial innovation is important because, and this does not necessarily only come from universities. It does not necessarily only come from companies or from governments. It comes from wherever it comes from. And so in the TransPod case, it came from the private sector, but is involving governments and universities worldwide. But the observation that we are having is that the governments that are recognizing the importance to their own productivity and competitiveness to begin participating in the development early benefits more in the long term. And so that benefit is partly from so being part of the patenting process in that country, being part of developing new education opportunities at universities. Once that is brought into, so TransPod is collaborating with universities, increasing number in Europe and Canada, US, and we hope to expand that in Asia as well. So when the universities are involved, then other nonprofit organizations and companies, each of those parts of the economy develop in their own level of productivity, and then they reap economic rewards. So that's been quite important for the TransPod's example. It's a multi-year development process. It starts both with the intellectual property, but also the manufacturing certification. And so in this case, all of the different subsystems are being developed together in different countries. And then leading towards certification in the mid-2020s and aiming to secure initial development of a line and then following additional lines. So an important aspect is that TransPod aims to manufacture the vehicles but not build the lines. So that's just the same as a train line. You often have a consortium where there's a major construction company, a major government backer, an operator, and financial backers, where they work together to do the construction in that particular city. So this was one example with the TransPod system, where we have fossil fuel-free high-speed transportation that's faster than a jet, 3 times as fast as a train. But we must step back and really look at all modes of transportation. So designing for future capacity. And so this, what we see here is global aircraft traffic between different cities and different countries. And so, of course, the TransPod system will not be replacing the cross-Atlantic or cross-Pacific aircraft travel, obviously, because of practical issues, where it's most suited to local intercity routes within a single continent. And at the same time, like I said before, the multimodal connections to that branched and last mile delivery is very important. So it's important in developing countries, it's important in developed countries, and so to intelligently design our countries and our urban fabric, we need to consider technology and we need to consider people and regulation together. So the goal with TransPod and the goal with any transportation system is really to have a holistic design. Holistic in a sense where we don't only consider the technology, we don't only consider the business case without any technology, but we must consider both of those together along with economic and human considerations. So it's almost a Leonardo da Vinci type of process where we must holistically think of all those aspects to intelligently design our transportation for the future and help societies both in a social and economic and productivity side. So thank you, and I will be happy to answer any questions.
Thank you, Mr. Janzen. Now we would like to open the floor for questions and answers. So if you have any questions, please raise your hand and we will bring a microphone to you. You may use either Japanese or English. Please keep the interpretation device on if you're using it. And also please state your name and affiliation before asking a question. Thank you.
Thank you for a very educational and informative presentation. I'm Abul Bashar from Asian Development Bank. My only question, maybe a very layman's question, do you think people will be really interested to ride on this kind of transport, which is kind of a sealed capsule in a sealed tunnel, right? And what will be the likely impact on their health? Thank you.
Exactly. So yeah, the human aspects are very key for the design. Now we have to look at examples that already exist. So examples, for example, in Tokyo, right here, people already travel on closed vehicles through tunnels where they cannot escape easily every day. People travel quite a long distance in tunnels, for example, between France and the United Kingdom under the English Channel. So that's an example of a tunnel or tube environment where you have to properly design all safety systems to account for all eventualities. So this is safety, certification, and designing for the human experience too. So making it a comfortable experience, a smooth ride, and also designing carefully for any kind of this is, even the medical field has very interesting observations on seasickness too. So it's for myself, I actually personally get a little bit seasick on certain types of bus travel or airplane travel. And that's very well researched, the exact vibration of the human body in each direction. So vertical direction, horizontal, different kinds of rotation. So that's well researched in the medical community. And for me, that's a good thing because that is definitely going into all of the computer control algorithms on the TransPod vehicle. So all of the real-time computer control is a bit like a flight control system, so it's maneuvering in 3D space to be able to give a comfortable and smooth ride.
Thank you. Does anyone have... Please.
Okay, good afternoon. I'm from Nepal, Anjana Tamrakar, NPO head. And actually, as you mentioned, you have to book the seat 1 month or 1 week before, and it may be very expensive. Is it possible for the general people, for the community people? How can they provide, or how can they arrange this type of tickets for this type of vehicles? Is it only for higher class or for the general public?
Okay. So, yes. So that's thank you. So that example I was giving was what is customary in the flight industry, so the aircraft industry, but with TransPod, the objective is to not do that. So have a much more easily accessible system So a system that's much more like a metro line, where you simply go to the machine, pay for your ticket, pay a small fee, get the ticket, and then walk to the platform to go to the next, to wait for the next vehicle. So that's the way that the TransPod line is being designed. But also the affordability, yes. And so that is very key. All of the ticket costing issues and the business case for the overall line, it's different in different countries. So for example, in some countries where there is a low population, if, let's say, the private sector wishes to support, then they will want to have a high ticket price to be able to recover their investment. But if you have a country where there's a high population, or a high population density, or you have a government which wishes to invest and subsidize this as a public service, because the productivity increases are so great, then you can achieve a very low ticket price that's similar to a train ticket. Yeah.
Thank you.